Assalamualaikum warahmatullahi wabarakatuh. We're gonna continue about the production of formaldehyde part 2. Okay, I'm Nurul Nazira. Okay, the market study worldwide. Market study of import and export of formaldehyde in Malaysia is not that huge if we compare to Europe and few other countries. As we can see in the table in the next slide, the import and export activity of formaldehyde worldwide in 2019. In Asia, just few countries that lead in imported and export activities, which are India, China, and Vietnam. While for the world largest importer of this community group in 2019 are first by Germany, followed by Belgium, Netherlands, France, and Poland. Okay, this is the graph of export and import 2019 of the formaldehyde production. Okay, we move to market study in Malaysia. The Malaysian formaldehyde market dropped to 23 million USD in 2010, declined by -7.4% against the previous year. The growth pace was the most rapid in 2009, an increase of 1.2% year over year. Formaldehyde consumption peaked at 26 million in 2007. The most prominent rate of growth were recorded in 2009 when the production volume increased by 2.8% year to year. Over the period under the review, production reached the maximum level of 26 million in 2007. We move to the consumption. In 2010, consumption of formaldehyde were finally on the rise of the reached 99,000 ton over 2 years of decline. Overall, consumption showed a pronounced contraction. Consumption reached the peak volume 66,000 in 2007. However, from 2008 to 2010, consumption stood at a somewhere lower figure. You can see at the table left. The revenue of the formaldehyde market in Malaysia fell to 23 million USD in 2010, winning by -7.4% against the previous year. The previous year 2009. The most prominent rate of growth was recorded in 2009 when the market value increased by 1.2% year over year. Over the period under the review, the market hit record highs at 26,000 million in 2007. However, from 2008 to 2010, consumption remained at the lower figure. Export of formaldehyde. Export from Malaysia. In 2020, amount of formaldehyde export increased compared to 2019. Over the period under review, export shown buoyant growth. The pace of growth appeared in the most rapid in 2012 with the increase of year to year. Export peak in 2020 are expected retain growth in year to come. Generally, the export record resilient growth. The most prominent rate of growth was recorded in 2020 with the increase year to year. Over the period under review, export reached the peak figure in 2020 and likely to continue growth in year to come. Okay, export of the country. Thailand, Philippines and Vietnam were the main destination of formaldehyde export from Malaysia from 2007 to 2020. In the value term, the Philippines, Thailand and Vietnam were the largest market for formaldehyde export from Malaysia worldwide. Among the main country of destination, Vietnam showed the highest rate growth. We move to the import. Import into Malaysia in 2020, after 2 years of growth, there was significant decline in overseas purchase of formaldehyde. The volume were decreases. The most prominent rates of growth were recorded in 2018 with the increase year to year. Imported peaked at the 2007. However, from 2008 to 2020, imported remained at a lower figure. In the value term, formaldehyde import declined significantly in 2020. Overall, imports show a drastic downturn. The pace of growth appeared in most rapid in 2018 with increase against the previous year. From year 2019 to 2020, the gross import remained at a lower figure. Okay, import by the country in 2020, Singapore constituted the largest supplier of formaldehyde to Malaysia. Moreover, the formaldehyde import to Singapore exceed the figure recorded by the second largest supplier, which are Saudi Arabia. The third position ranks by the South Korea. Okay, we have the global and local competitor, which are the global stated in the table, such as Johnson Matthey Process Technology, Format Performance Chemical, Huntsman International LLC, and many more. So for the local, there are about five formaldehyde production that quite huge in our country, which are located at Lunas Kedah, Shah Alam, Bintulu, Kuantan Pahang, Seberang Perai Tengah, Penang. The volume formaldehyde itself is like eliminate any unnecessary dilution, so it will help to help the minimization. And next, do not mix the waste stream, like separate the waste stream. This will help to minimize the waste. So that's all from me. I'm pass to the next person. Thank you.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afrika. So I would like to continue my presentation on the process specifications part 2. Okay, so basically I already explained about the process specification for the equipment under the reactor. So today I would like to explain more on process specification for two equipment, which is absorber and also separator. Okay, so firstly is absorber. Okay, what is absorber? Absorber is a typical gas liquid contacting operations, which is the gas here will move or will travel up through the vessel, or the absorber is liquid and gradually removed from the gas. Okay, so the absorber actually also maybe have a packet column, bubble column, spray column, and why we choose a packet column. Okay, as you know, the figure shows here is actually a packet column, right? Okay, we choose packet column for our productions. This is because the packet column has advantages where the corrosion control is essential. Okay, since we are dealing with the methanol and also other substances that quite corrosive, we need packet column compared to other column in order to handle corrosive substance, and also in order to handle a toxic and flammable liquids. Okay, next, packings. We choose the absorber packing is metal pulp rings. This is because firstly, metal pulp rings is more suitable compared to plastic pulp ring because it has better corrosion and rust resistance, and also has a higher mass transfer efficiency and also better liquid or gas distribution. This is because, as I told you just now, that our production is dealing with the corrosive substances. Therefore, we need metal pulp rings as a backing for the absorber. Okay, so next. Okay, so next is the specification sheet for the absorber. Okay, as you see here is a absorber for the T100, and also the operating pressure shows the values of 100 until 130 kPa. This data is I obtained from the HIC simulation. The function of the absorber is to absorb the methanol and also in order to obtain the product without any gas. This is like off gas lah. And this is our product here, which is contain formaldehyde. Okay, so next is also the absorber, but this absorber is contains the reboiler, which is we need second absorber in order for our production to become more efficient. This is already explained by ICA. for high-C simulation. Okay, so here the data from here is I already obtained from the high-C simulation, where the operating pressure is 100 kPa until 100 kPa. The operating temperature is 70 degrees C and until 104.8 degrees C. Okay. So next is the separator. Okay, so what is separator? Separator actually is a vessel used to separate the gas and also the liquid components from the fluids extractions. Okay, so this actually have many types of the separator. It has two-phase separator and also three-phase separator. Okay, why we need two-phase separator for our production? This is because, firstly, two-phase separator is best suited for streams with high liquid content and also low gas volume, where it extracts the liquids from the natural gas. Okay, next, a two-phase separator, it only need to separate the liquid and also the gas, compared to three-phase separator, which is separate well fluids into H2O, oil, and also gas. Since our productions is occur only like liquid and water and also gas, which is we doesn't use any oil, no oil. Therefore, our production of formaldehyde only need two-phase separator. Okay, here is like liquid and also the gas. Since we doesn't have any oil, okay, and here is a two-phase separator diagram. Okay, where as you can see here, the outlet is like vapor and also the liquid, no oil. Next is a specification sheet for the separator. Okay, it want to separate unwanted gases with unwanted gases, which is CO2 that we doesn't want in our product, with our methanol and also H2O. And the data here is obtained from the high-C simulation. That's all from.
Assalamualaikum and hi, my name is Siti Zulaika binti Ruslan. So in part 1 we already have done up until the reactor unit only, and I will continue to the last part, which is a complete high-C simulation of formaldehyde production. So first we look into the separation unit. In our project we use absorber unit. So what is the need of the absorber unit? The main objective of the absorber stage is to condense formaldehyde, methanol and water, which may contain a selection of backing, trace and other features to promote the absorption, and in order to optimize set of operational conditions and increase efficiency of the absorber. One study has been made by Winkelmann 2003, which is to apply two sequence of the absorber column. The separation unit may compress absorption to extract the formaldehyde product from the oxidized gas mixture. The reason why we don't apply this distillation column here, because this sequence absorber has superior convergency and stability characteristic rather than distillation column, which is the distillation will give more calculation and iteration resulted to unconverged system. So let's start with the high-C simulations. We continued with the product from the reactor. After the product from the reactor have been cooled down, which is from 650 degrees Celsius to 100 degrees Celsius in order to prevent any thermal decomposition of formaldehyde, where in this case we apply the network heat exchanger circuit to create a circulation of the water. This product is then being fed to the absorber column 1, and in absorber the water is fed at the top of the column to reduce the emissions of formaldehyde and methanol from the column. The top pressure of the column is 1.4 bar and the bottom pressure is 1.5 bar. The pressure at the top column must be lower than the pressure at the bottom to avoid any backflow and flooding in the column. And the formaldehyde is absorbed in water because formaldehyde is a poor gaseous form and highly unstable. It also because the reactor product stream contains of formaldehyde diluted in other gases, mainly nitrogen. As you can see here, the composition here is mainly nitrogen. So that's why the water must be fed at the top stream. Of gas that emit from this absorber will then burn, and suggested by Bowman et al., this combustion also gave benefits in reducing environmental emissions. So mostly the absorber is packed with porine, and if proper packing size and cooling can be maintained, then more than 95% absorption is completed. And in our project, formaldehyde is 99.99%, which is, as you can see here, only 0.004 not absorbed. So next, stream 18 enter to the reboiler absorber since there were still unabsorbed gases from column 1. Considering our final product only contain formaldehyde, water and unreacted methanol, the reboiler will continuously boil the liquid to make sure that all the excess gases condense and leave at stream 20. Since this is an exothermic process, Q9 will supply heat to the reboiler. For stream 19, it acts as a recycling stream for methanol because we want to make sure that methanol level always in the column. The needs of methanol recycle in this column because methanol is oxidized to formaldehyde and methanol is present as a stabilizer in formaldehyde solution since it enhances the solubility of formaldehyde by preventing the formation of solid formaldehyde. In this case, we monitor the column by set the reboiler temperature column at 104.8 degrees Celsius, since formaldehyde must be in range 20 to 105 degrees Celsius. We try to monitor the temperature in the range, but only 104.8 degrees Celsius resulted to converge and less iteration is needed. The unwanted gases were 100% removed at stream 20. As you can see here, our product only consists of methanol, formaldehyde and water. After that, this gas stream will then cool down in order to be fed to the separator in mixture phase. This separator was used to separate all the gases and liquid because we want to recycle back the liquid methanol. This T100 will split the recycled stream to T101 and another one will mix at the methanol at the first stream. To conclude all of this, the formaldehyde product that we achieve at product stream is 39.73% with 0.0383 of methanol and the rest is water. We can achieve about 2.73% more than standard producing data, which is 37% weight per weight as stated by VM Buyanos. That's all from us. Thank you.